Hi, I'm Lydia, a former data scientist on the DSDP, and now working as a member of the DAP team as a research software technician. I work on the project Curriculum Redefined, which is designed to enhance student experience through the evaluation of a curriculum and portfolio enhancement project. Here I've been exploring how we can use NLP to understand curriculum change. Imagine I'm a large language model, and the Leeds City Centre is a physical representation of the big text corpus I'm trained on. The spaces and things in the city stand in for the words. I've learnt language and its context in a very general way by just walking about and paying attention. Then my mate Bert Topic, the topic modeller, steps in to group those words into themes. For example, on Brigger you might get restaurant, bakeries, shops, people and tall buildings. At the train station it's people, tickets, queues, trains. In the pub I'd expect to see words like a glass, bar, bar mat, beer, and even these days coffee. What I don't expect to find in the pub is a toothbrush. This throws me off completely. What is a toothbrush doing in the pub? So I take it to where it seems to belong most, by a sink or in a dental suite. The only trouble is, today in the pub is a dental conference going on in the higher room. So now it makes sense why there's a toothbrush in the pub, but only in the right context. This is kind of like the curriculum data I'm working with. It's very domain specific. For example, credit in English means things like recognition or money, but in context of the curriculum syllabi, it is a numerical value assigned to a module. This method of training topic and language models on domain-specific language in this instance is called DAPT, or Domain Adaptive Pre-Training. I'm using this method, along with cosine similarity, to uncover themes such as sustainability and global citizenship in the context of the curriculum, to understand its impacts on different student demographics. So, how does this look in practice? First, I was given a list of 7 key themes like assessment, sustainability and global citizenship, to look for in the text using natural language processing. I used a mini language model called Mini-LM to search through the module corpus to find semantically similar keywords. The difference between large language models like ChatGPT and mini language models such as Mini-LM is that Mini-LM doesn't generate text, it just understands it through embedding numbers into the text. For example, every word or part of a word is assigned a 384 numerical value. Take for example the word education. Its 384 numbers capture its meaning. Some numbers represent what kind of word it is, like noun or adjective. Other numbers represent if it's a formal or casual word. Other, its tone or its domain. It's basically a numerical semantic fingerprint of the word. In Dataland, these fingerprints are called vectors. Words that are semantically similar will have a similar number structure. Mini-LM is a smaller version of Google's BERT, and I pre-trained it on the module corpus. Alongside Mini-LM, I used a sentence transformer. Instead of embedding each individual word with 384 numerical values, it zooms out and it looks at the whole of the module. If a module description is about environmental awareness and sustainability with peer review assessment, that will be represented in the 384 numerical embedding. Now I have embedded meanings at module level to see how they match up with the themes. To do this, I use cosine similarity. Cosine similarity, like sentence transformers, rely on embeddings, but instead of creating the embeddings, it compares them, outputting a table like this. As you can see, when I organise it by most similar for sustainability, as expected we see modules from the environment faculty pop up. I think the theme matching number could be higher, so it's telling me that my adapted model needs more fine-tuning. This resulting data has then been used to create an app where you can aggregate and sort data by years, themes, schools, and it will show you a line graph of how those themes appeared over time and in what modules. The next step is to input demographic data to see the relationship between the key themes and the student outcomes. Thank you for listening to my Flash Talk.